Greetings everyone. We will continue our discussion on programming for problem solving using C. In the previous session, we have started about arrays and we have discussed about one-dimensional arrays. That is, how to declare one-dimensional arrays and how to give values into the one-dimensional arrays and how to read the data from the one-dimensional arrays. In this session, we will be going for the next topics regarding two-dimensional arrays and multi-dimensional arrays. So, as a part of this two-dimensional arrays, in C programming, we can create an array of arrays. So, this array of arrays will be calling it as multi-dimensional arrays. Okay. So, when you are creating a single dimensional array, as I told you, your one-dimensional array will be a conceptual view of a row. That is, you will be having a list of values in this manner. We will be having a list of values in this manner. This is one-dimensional array. Okay, when you create a one-dimensional array, that is, when you want to create an array of arrays, that is, when you want to create, this is one array, when you want to create an array of arrays, this will be one array, this will be another array, this will be third array, this will be the fourth one-dimensional array. This creation of arrays will be calling it as multi-dimensional arrays. So, multi-dimensional arrays are arrays with two or more subscripts. Okay, when you are creating a one-dimensional array, I think you remember you are going to use one subscript, that is one square braces, that's there where you signify the number of elements there, and we will be using one subscript or one index. When you are going for multi-dimensional arrays, that is, when you want to have a two-dimensional array, we will be having two subscripts, and when you want a three-dimensional array, we will be having three subscripts. Based on the number of subscripts you are having in your particular array, we will be having the dimension array. That is, this will be a two-dimensional array, this will be a three-dimensional array, four-dimensional array, in that manner. So, all the two-dimensional array is also called as a matrix. So, when you are using a two-dimensional array, okay, this will be one type of two-dimensional array where we will be calling it as a matrix. So, a matrix will be represented as a two-dimensional array in your programming. So, I think you already know how you represent matrix in your general mathematical terms. That matrix will be representing in even a programming language by using your two-dimensional arrays. So, we are going to apply all the concepts what you have learned in your one-dimensional array in your two-dimensional array. So, a two-dimensional array or a multi-dimensional array will be like an array of arrays where you will be having more than one subscripts. So, a declaration of a two-dimensional array. So, I think you know how to declare your one-dimensional array, where you will be specifying the data type first. After that, you will be specifying the array name. Then, in the one subscript, you will be specifying the size. This will be your one-dimensional array. Okay. When you go for a two-dimensional array, so you have to specify the data type first. After that, the array name, and you will be having two subscripts. The first subscript specifies the row size and the second subscript specifies the column size. So, you have to specify the array name first, after that, the data type, after that you have to specify the array name, then you have to specify the row size, then the column size. Okay, the row size and then the column size. So, wherever you specify, that is the first subscript implies the rows and the second subscript implies the columns. This will be the rows and this will be the columns. So, I think if you take a 3x4 matrix, okay, so where you are having 3 rows and 4 columns. So, I think you can see this a two-dimensional array. This two-dimensional array can be seen as an array of arrays. That is, you can see the two-dimensional array as an array of 3 one-dimensional arrays. This will be the one-dimensional array, this will be another one-dimensional array, this will be another one-dimensional array. So, we can see this particular two-dimensional array as 3 one-dimensional arrays. So, whenever you have this particular value, you can see this as the number of rows you are going to represent. or the number of one-dimensional arrays you are going to have. That is, a two-dimensional array will be having 3 different one-dimensional arrays. So same thing what you have done in the previous one-dimensional arrays, those operations can be applied here as well. Okay. So the first thing, the first subscript signifies the row size and the second subscript signifies the column size. So when I say 3 by 4, I am going to say my particular two-dimensional array is going to contain 3 rows and 4 columns. So completely 12 elements it is going to contain. So here X is a two-dimensional array and the array can hold 12 elements. You can think an array as table with 3 rows and each row has 4 columns. We can think it as 3 rows and each row has 4 columns. Okay. We can think as 3 one-dimensional arrays and each one-dimensional array has 4 elements. Okay. This is how you have to view your two-dimensional arrays. So you can see the same thing here. You will be having your same row. You can think int x where you are having 3 rows and 4 columns. Okay, this will be the declaration. You can think the particular subscripts in this manner. So this will be the first row and first column. I think you can visualize this as one-dimensional array. This is another one-dimensional array. This is one-dimensional array. In the one-dimensional array, I think you remember the subscripts will start from 0, 1, 2, 3. Okay, 0, 1, 2, 3. Okay, since this is the first one-dimensional array, you have to have the subscripts in this manner. So the first element will be identified by 0, 0 index. The second element will be identified by 0, 1 index. The third element will be identified by 0, 2 index, and the fourth element will be identified by 0, 3 index. Same is the case for your second row. So in the second row as well, since I can treat it as a one-dimensional array, your index start from 0, 1, 2, 3. Okay, and since this is the second row, so your first row is represented by 0, your second row will be represented by 1. Okay, your second row will be represented by 1. Okay, same is the case your third, 0, 1, 2, 3, and since this is the third row, it will be represented by 2. Okay, so in this manner your complete subscripts or indices will be present for each and every element. Okay, the first thing will signify the row which you are using and the second thing will signify the column. So if you see the first row, everything will be 0. The first element, the first index, this will be your row index and this will be the column index. So the row index is 0, 0, 0, 0 and the column index is 0, 1, 2, 3. So if you see the column index, this will be 0, 0, 0 and the row index 0, 1, 2. So you have to remember or conceptually visualize all these element indices. So 0, 0, 0, 1, 0, 2, 0, 3. That will be the first row. 1, 0, 1, 1, 1, 2, 1, 3. 2, 0, 2, 1, 2, 2, 2, 3. So these will be the indices for each and every element that are present in your complete matrix or your two-dimensional array. So your indices will start from 0, 0 and it will go on until to the right to 0, n minus 1 columns. Okay, and there will be m minus 1, 0 to m minus 1, n minus 1. If your array is of size m by n, if your array is of size m by n, okay, your indices will start from 0, 0 to m minus 1, n minus 1. These will be the indices which will be present for each and every element in your complete two-dimensional array. So a two-dimensional array can be visualized as different one-dimensional arrays, okay, where you can visualize them as a matrix or in terms of rows and columns. Okay, based upon the row numbers and column numbers, their indices will be present. You have to be able to visualize this so that you will better understand your programming part. Similarly, whatever you have done for a two-dimensional array, the same thing can be applied for multi-dimensional arrays, that is 3 dimension, 4 dimension. Okay, so when you see a two-dimensional array, you are declaring in this manner int x, that will be 3 by 2 means this will be 3 rows and 2 columns. This will be a two-dimensional array. So if you go for more than one dimension, if I go y 2 3 2. So since you are having 3 dimensions, this will be calling it as a 3-dimensional array. So how many elements it can fit? This will be 2 into 3 into 2. So many number of elements it can fit. But how to visualize this thing? So when you go for a 2-dimensional array, you can visualize it as 3 rows and 2 columns. 3 rows and 2 columns. That is, you are going to have 3 one-dimensional arrays of 2 elements. Okay, 3 rows and 2 columns. 3 rows means you will be having 3 rows and 2 columns means you will not be having this element 3, 4, 5, 6. That will be 3 rows and 2 columns. So if I have this 3-dimensional array, so on the right you are having 3, 2, so there will be 3 rows and 2 columns, and this will be the plane. So this will represent the plane in a 3 dimension. This will represent the row and this will represent the column. Okay, in a 3-dimensional array we will be having this represents the plane, this will represent the row and this will represent the column. So you will be having 3 by 2 arrays, that is 1, 2, 3, 4, 5, 6. This will be plane 1. In the same manner you will be having 1, 2, 3, 4, 5, 6 and a plane 2. Okay, when you want to visualize a 3-dimensional array, you can think it of 2 3 by 2 matrices. 2 3 by 2 matrices. So in this manner you can visualize this particular 3-dimensional arrays. So this the last part will represent, that is the first part will represent your plane, and the second part will represent the row in that plane, and the third part will represent the column in that plane. So this will be plane 1 and you will be having these values, and plane 2 you will be having another 2 by 3 matrix. So this will be 3 by 2 matrix and this will be another 3 by 2 matrix. So you will be having 2 3 by 2 matrices for this particular 3-dimensional array. If you go for this one where you are having float y 2 4 by 3, so we can think it as 2 4 by 3 matrices. Okay, or 2 4 by 3 2-dimensional arrays. Okay, so we will be having one 4 by 3 in first plane and another 4 by 3 in the second plane. So how to look at it as the indices? So here your indices will start from 0 0 0. That is, since it is a 3-dimensional array, it will be having 3 indices. Okay, so 0 0 0 and the same manner 0 0 1. Okay, 0 1 0 0 1 1 0 2 0 0 2 1. So the first part will represent the plane. So since it is a first plane, I am signifying with 0. In the same manner, second plane 1 0 0 1 0 1 1 1 0 1 1 1 1 2 0 1 2 1. So those will be the indices for each and every element that are present in that particular 3-dimensional arrays. So the same concepts can be applied for 4-dimensional or more dimensional arrays. So you'll be having numerous applications with matrices. So you should be able to better comprehend what is the meaning of each and everything. That is how to declare a 2-dimensional array and the 3-dimensional array. So you will be declaring your 2-dimensional array by specifying these row and column sizes, and you can declare your 3-dimensional array by specifying the row size, column size along with the plane size. So this is how you can declare both your 2-dimensional arrays and 3-dimensional or more dimensional arrays. So how to the second part, that will be the declaration part. So I think you remember. So in our array applications we will be doing the 3 and 4 parts, that is your declaration, input, processing out. So we'll be performing the 4 operations in your arrays. The first part is declaration, how you are going to declare. The second part is how you are going to give values into the array. The third one is what is the process you are doing, or what is the application you are performing on that array. And the fourth one is what will be the output of performing that application. So the next part, after the declaration, you have completed the declaration part. The second part is giving values into the array. So one way to give values into your array is the initialization. Initialization will come while declaration of your array. So you have already done that in your one-dimensional arrays. So in one-dimensional array, your initialization will be in this manner, where you will be giving values 1, 2, 3, 4 like this. Okay, you will be giving your values in this manner. The same thing in a two-dimensional array, you can give values in this manner while declaring itself. So while declaration, you have to first specify your data type, then your array name, then you have to give the row size and column size. After that, if you see, you are opening one flower base. Inside that flower base, I am writing the first row values in one flower base, comma, the second row values in another flower base. After that, close the main flower base and semicolon. So what you have to do is, you have to give the rows with separated values. That is, you are giving one-dimensional array in this manner. The same manner you have to specify the one dimensions one after the other, or you can view it as the rows one by one. Okay, first row values, comma, second row values, comma, third row values, in that manner. Or you can give values in this manner, where you need not specify the row values. Just you can give 1, 3, 0, -1, -5, comma 9 like that. So when I give values in this manner without any separation like this in rows, it will automatically say, when you specify, see 2 by 3. 2 by 3 means you are going to take first 3 elements for the first row and second 3 elements for the second row. So that is all. The third method is, you need not specify the row size. Okay, you need not specify the row size. When I am initializing my arrays while declaring, I need not specify the row size. If you don't specify the row size, what will happen? So based upon the column size, it will take the rows. That is, so since you have to damn sure specify the column size. If you don't specify the column size, it will be giving you an error. So when I specify the column size, what it has to do? It will take the first 3 elements to the first row, and the second 3 elements to the second row, and 3 elements to the next row. Based upon that number of 3 elements, it will create the rows. So if I am having 9 different elements in this particular initialization, I can think it as 3 rows. Okay. So but while declaration, you can skip the part of specifying this row size when you are initializing in this manner. These are the 3 different ways you can initialize your two-dimensional arrays. The same is the case with your 3-dimensional arrays. So this is the initialization of a 3-dimensional array. So here you are specifying a 3-dimensional array of 2 3 by 4. So you will be having one 3 by 4 matrix and another 3 by 4 matrix. So you will be having 2 3 by 4 matrices. So this will be one 3 by 4 matrix. Okay, this will be the one 4 elements, another 4 elements, another 4 elements. This will be the one 3 by 4 matrix. This will be another 3 by 4 matrix. Okay, how to specify all the values based upon the rows you have in your particular plane. So this will be represent one plane. This will be represent one row column like that. So you should be able to comprehend how you are initializing these 3-dimensional arrays. So your 3-dimensional arrays will be 2 3 by 4 matrices. So that is how you have to implement your 3-dimensional arrays. So the first part, declaration. While declaration, if you want to initialize, you can initialize them in this manner. If you don't want to initialize them, you have to give them as input to the array. Okay, if you don't want to initialize those values, or you have to take the values from your keyboard, then you can use your inputting method using scan. So if I want to give values through the keyboard, I have to use your scanf function. So while using scanf function, I have to access all the elements in your two-dimensional array. So if you are having a 5 by 4 matrix, where your 5 will be your rows and 4 will be the columns, then you should be aware of your indices. That is, it will should start from 0, 0, 0, 1, 0, 2, 0, 3. Okay, this will be the rows 1, 0, 1, 1, 1, 2, 1, 3. In a similar manner, 4, 0, 4, 1, 4, 2, 4, 3. This will be our 5 by 4 matrix with the set of indices. So in order to access the first element, I need to have 0, 0. Next, the second element 0, 1. So to access each and every element in your complete matrix, I have to use this method, where you have to specify 2 for loops. Okay, one for loop for the rows and the second for loop for the columns. Okay, the second for loop for the columns. So how it will work? That is how you can give values or how you can input values into the array. So first I have given I value is equal to 0. So I value will be 0. Okay, since I value is less than 5, it is okay. It will go into the inner for loop. Inside I have given j value is equal to 0. Okay, I have given j value is equal to 0. J is less than 4. It is fine. Okay, it will go into the for loop. Enter value for your ABC, that is 0, 0, and enter the value for 0, 0. It is saying enter the value for 0, 0. That particular value will go into address of ij. Ij value is 0, 0. That is, it will go into the position of A0, 0. So whatever you enter, it will go into the position of A0, 0. So next, after completion of this loop, j will be incremented. J will become 1. J will become 1. Again, this loop will repeat. Now A of 0, 1 value will be taken for input. A of 0, 1 value. First you have taken A of 0, 0. Next you have taken A of 0, 1 value. So the 0, 1 value will be taken. Again the for loop will repeat. Now j value will become 2. Next you will be taking A of 0, 2. Next j value will become 3. You will take the value 0, 3. Next j value will become 4. So when j value becomes 4, 4 is not less than 4. So the for loop will exit. So once it exits from here, it goes back to the I loop. That is, now I value will be incremented by 1. I value will be incremented by 1. Now I will be 1 now. So now again it will go into the j loop again. You should have seen this inner for loops, that is nested loops in your for looping statements. Now j will again start from 0. Next it will go to 1. J will go to 2. J will go to 3. So when I value is 1, it will go for the second row. So I value 1, j value 0. I value 1, j value 1. I value 1, j value 2. I value 1, j value 3. So it will take the input of your second row. Again I value will become 3. It will take the input of the third row. In the same manner, you are going to take the input of your all rows present in your complete matrix. So whenever I want to implement the input method for your matrix, I have to use 2 for loops. Okay, the first for loop will represent the repetition of your row. The second for loop will represent the repetition of your column. For each and every row, I have to repeat all the columns. That is why the inner for loop will be present for your columns. Okay, this is how you take the input for your two-dimensional array. So the same thing, how to read data, that last part, that is how to read the data from your two-dimensional array. So in the previous part, I have given data into the two-dimensional array by using your scanf statement. Next, I have to read the data from the two-dimensional array, whatever that is present. You have to use the same process, that is you have to take the same 2 for loops one for loop which represent your rows, the second for loop which represent your columns, and inside I have to specify I of ij. Ij will represent your rows and columns. So this is how you will be reading your values from your complete two-dimensional array. So this will be all the parts regarding your two-dimensional arrays. When you go for a three-dimensional array, you will be getting another for loop. That is, you are having two-dimensional arrays, so we are having two for loops. When you are going for a three-dimensional array, we will be getting another third loop. Okay, so which represents your planes. So that is about taking all the parts of your complete two-dimensional array. So we'll combine all these parts of your two-dimensional array and calculate average of your elements present in your two-dimensional array. I will take a simple two-dimensional array. So we'll write the complete program regarding your calculating averages present in your two-dimensional array. So in order to calculate average, I should first take one array, okay, one matrix. So I will take a two-dimensional array. So for that, you start including your standard input-output header file. Next, main. Inside the main, first what I have to do is I have to declare one two-dimensional array. So I will declare a two-dimensional array with 2 rows and 3 columns. 2 rows and 3 columns. This is just a declaration. Once after declaration, what I have to do is, so once if I declare a 2 by 3 array, so there will be some garbage values, some random values, 2 rows, 3 columns, some garbage values will be present in the 2 by 3 array. Now what I have to do, I have to give values into that array. Okay, I have to give values into that array. To give that values, I need 2 counting variables I and j. Once after giving values, I have to sum those values. So I will take a sum variable and initialize it to 0. Once after calculating the sum, I have to average. So I will have an average and initialize it to 0. These are the declarations that are present for your program. Now once after declaration, what I have to give? I have to give values into that particular array. So to give the values for I is equal to 0, I less than how many? We are having 2 rows. So less than 2 rows, I plus plus. For j is equal to 0, j less than 3 columns, j plus plus. Okay. Scanf %d address of a I j. So this is how you give input into your particular elements. So you have to give values. So let's take some values 2, 3, 4, 5, 6, 7. So this part will give values into the array. So now 2, 3, 4, 5, 6, 7 values are present in that two-dimensional array. So once after taking the values, what I have to do? I have to take the sum. So to sum, what I have to do? The same thing, I have to read each and every element, that is, I have to read the 0 element, 0, 1 element, 0, 2 element, I have to read the element row by row and take the sum of all those elements one by one. So, I less than 2, I plus plus, for j is equal to 0, j less than 3, j plus plus. In the last session itself, I told you how to sum the values in your array. Sum is equal to sum plus a of I. So this is how you will sum all the elements that are present in your array. Once after getting the sum, that is, you will be calculating the complete sum part here. After completing the sum, I have to calculate the average. That is sum by, so the total number of values you are having here is 6. Okay, that is 2 by 3. You can add the rows and columns separately if you want. So that will be the average. So average is percentage F, it is AVG. So this is a complete program to calculate averages of all the elements that are present in your two-dimensional array. So what you have to do, first you have to declare the elements on a two-dimensional array. Then after declaring the elements, I have to give values into the two-dimensional array by using your scanf. After that, you have to read each and every element one by one, that is row by row and one by one, and take their sum, okay, which will be present in the sum variable. After that, I have taken the average of all the particular values. So, and I am printing the average at the last. This is how you calculate the average of the set of values that are present in your array. Okay, so this is about your two-dimensional arrays. The same case can be performed for your three-dimensional array. So you can, I already told you how to declare your three-dimensional arrays. So you'll be able to declare in this manner, that is 2, 3, 4. Okay, where 2 represents the planes, 3 represents the rows, and 4 represents the columns. That is, you will be having 2 3 by 4 matrices. This will be one matrix, this will be another matrix. Okay, 2 3 by 4 matrices. That will be your three-dimensional array. And initialization part, while declaring itself, if I want to initialize, if I take a 2 by 2, okay, so I have to initialize. How you have to initialize? You will be having 2 2 by 2s. That is, this will be one 2 by 2 and this will be another 2 by 2. 2 by 2 means this will be, I will take 1, 2, 3, 4. This will be 4 values. 5, 6, 7, 8. So I have given 8 values which will be present in 2 2 by 2 rows. Okay, so this will be present 1, 2, 3, 4. This will be present as the first matrix in the first plane. This will be present as 5, 6, 7, 8. This will be present as the second matrix in the, so that is will be present as the matrix in the second plane. This will be plane 1, this will be plane 2. Plane 1 is, this represents your planes, this will represent your rows, this will represent your columns. So that is how you have to visualize your three-dimensional arrays. So your 3 dimensions are nothing but your number of 2-dimensional arrays. So this will be 2 3 by 4 2-dimensional array. This will be 2 2 by 2 2-dimensional arrays. The same case you can go for 4 dimensions as well. And how to read and write data from the 3-dimensional arrays. As I told you, in a 2-dimensional array I am using rows. I am specifying the rows. Next I am specifying the columns. J is equal to 0, J less than columns, J plus plus. We are using A, I, J here. So this is how you will be reading. If you want reading, I will be specifying scanf. If I am writing, I will specify printer. So this is how you will read and write for your 2-dimensional arrays. So if I want the 3rd dimension, I will be specifying for K is equal to 0. K is less than the number of planes you are having. K plus plus. Okay, so don't get confused by this. If you are having your array in this manner, that is planes, rows, columns. Okay, in this example I have represented your planes with K, rows with I and columns with J. In your text, this generally will be represented by I, this will be represented by J, and this will be represented by K. That is, planes will be represented by I, J, K, like this. We will be following a pattern I, J, K. But in this example, I have taken the 2-dimensional array, same I, J, and to represent the planes, we have taken the K value. Just don't get confused by the notations here. Okay. This is how we'll be reading and writing into a 3-dimensional array. And as you have seen how to create your 2-dimensional arrays and 3-dimensional arrays, you should know how to declare your 2-dimensional arrays and how to give values into the 2-dimensional arrays and 3-dimensional arrays, and how to read the values from the 2-dimensional arrays and 3-dimensional arrays. In the next session, we will be looking about what are the applications with which, that is, what are the applications which can be performed by using all these 1-dimensional, 2-dimensional and multi-dimensional arrays. Thank you.